In this video, I'm going to show you how to solve a radical equation, and here I have two separate examples. So first, you know that you have a radical equation if you have an equation with a radical in it. And in this first example, you can see I have a square root, and in the second example, I have two square roots. But you could have a radical of any index in your equation. I'm just going to be working with square roots for the purpose of this video. So let's work example A first. So the first thing I want to do is isolate this radical on one side of the equation. So first thing I'm going to do is add 1 to both sides. Now that I've isolated this radical, what I want to do is raise both sides of the equation to an exponent so that that radical will cancel out and go away. So since this is a square root with index 2, I will raise both sides to the power 2. Now it's very, very important that you raise the entire side of this equation to that exponent, not each piece separately. If you raise each piece separately to the exponent of 2, you'll get a completely wrong result. So, like I said, this square and square root will cancel, leaving behind just 1 minus x, while on the right-hand side, I need to actually multiply this out. X plus 1 times x plus 1. So I need to multiply this out. Now I can see what's left behind is an equation without any radicals in it. And at this point, it will be a type of equation that you've seen before. In this example, we are going to need to solve a quadratic equation. And I can tell that it's quadratic because it's degree 2. So in order to solve this quadratic equation, I'm going to collect all terms on one side of the equation, leaving 0 on the other. Now, I can solve this quadratic using any of the 4 methods that we've studied previously. I'm going to use factoring. Okay, now here's the thing with radical equations. You absolutely must check your answers back in the original equation. I do not know for sure that these are both solutions to this equation. So that's what I'm going to do down here, is check the solutions. And you have to check each one separately. So I'm going to substitute 0 back into this equation and make sure it gives me a true statement, and I'll do the same thing with negative 3. So here I've substituted in 0 for the variable, and I'm checking to see if it's really a solution. And sure enough it is. That works out just fine. Now I'll do the same thing with negative 3. Just substituted in negative 3 for x. And I'm wondering, does this work out? Nope. 2 minus 1 is positive 1, which is not the same as negative 3, which means the solution set for this equation is just 0, while negative 3 is considered an extraneous solution. So this is not a true solution to the equation. I thought it was based on solving this quadratic right here, but turns out it's not really a solution, so we call this extraneous. So when solving the second equation, I want to attack this exactly the same way, but you'll notice I have 2 radicals instead of 1. So what I'm going to do is try my hardest to isolate one of the 2 radicals. It doesn't matter which one. I think I'll isolate this first one. Now that I've isolated one of the radicals, I'm going to raise both sides to an exponent. And that exponent depends on the index on your radical. Since this is a square root, I will square both sides. Remember, you must square the entire side. So over here on the left, the square and the square root will cancel. Over here on the right, I have to multiply this quantity by itself. Now I have a negative times a negative. Square root of x plus 2 times itself is the same as squaring it, which means I get just x plus 2. Now what I've done is I've eliminated one of my radicals, and you can see I do still have one left behind. So I need to repeat this process. I need to isolate this one radical right here and then square both sides. So I'm going to repeat these same couple steps here, right here. Okay, so I've isolated the radical right here. Again, since the index is 2, I will raise both sides of the equation to the power 2, which will tell me x plus 2 is equal to 1, and solve for x. And I always need to check my answer. So I'm going to check this solution right here. I need to substitute this back into the original equation before I did anything and check to make sure that it really is a solution. So this is the square root of 0 plus the square root of 1. Is that equal to 1? It absolutely is. So the only solution I have to this equation is -1. So again, the solution set in this case is just one number, -1. And this problem over here did not have any extraneous solutions, while the previous one did. So remember, the tactic is to isolate either the only radical in your expression or at least one of the radicals in your expression. And you want to keep doing this until you've eliminated them all and you can actually solve for your variable. And as always, you absolutely must check your solutions on a radical equation.